All right, today we're going to pull back the curtain on one of the most important but usually invisible things in our digital world, the database transaction. It's the silent guardian, the unsung hero that keeps all our data safe, and we're about to see exactly how it pulls it off.
I mean, seriously, have you ever really thought about this? You tap send on a payment app. What magical process is happening behind the scenes to make sure your money doesn't just, poof, vanish into thin air if your connection drops? The answer is actually pretty brilliant.
So at its most basic level, a bank transfer is just a simple two-step dance. Step 1, the system takes the money out of the sender's account. Step 2, it puts that same amount into the receiver's account. Seems easy enough, right? But what if the system crashes right there, right between step 1 and step 2?
Boom! System error. And that is the nightmare scenario. If the process fails after the money's been deducted, but before it's been added to the other side, that 100 rupees is just gone. It's not in account A anymore, but it never made it to account B. That's a huge problem, and it's exactly what we need to prevent.
And this is where our hero of the story steps in. The transaction. It's this powerful but simple idea that developers use to stop these kinds of disasters from ever happening. It ensures that our data operations are safe and reliable every single time.
The big idea here, the absolute core principle, is all or nothing. A transaction basically bundles those two separate steps, taking the money out and putting it in, into one single unbreakable package. You can think of it like a safety bubble. If anything at all goes wrong inside that bubble, the whole thing gets canceled, like it never even happened.
So, how do you actually control this safety bubble? Well, it turns out developers have these 3 magic commands that give them total control. Let's see how they work.
Okay, here's our bank transfer again, but this time we're going to do it the safe way. First, we say begin transaction. That puts up the walls of our safety bubble. Then, inside the bubble, we do our 2 updates. Take from account A, give to account B. And only if both of those steps work perfectly do we give the final command, commit. Commit. Think of it as the giant final save button. Hitting commit tells the database, okay, everything inside that bubble I just did worked out great. Lock it in. Make it permanent. It's the point of no return. But what happens if something does go wrong? An error pops up mid-transfer. That's what rollback is for. It's your escape hatch, your big red undo button. The second it's called, it just erases everything that happened inside the transaction and puts the database back exactly the way it was before we started. No harm, no foul. So when you boil it all down, it's this super simple choice. You either commit to finalize the deal and make it real, or you roll back and cancel the whole thing. It's this clear 2-option system that gives transactions all their power and safety. Now you might be wondering, how can this be so reliable? Well, it's all built on this solid foundation of 4 strict promises. And together, they have a really cool acronym, ACID. This is what makes transactions so darn trustworthy.
And listen, the source material for this explainer really flags this part as very important, with fire emojis and everything, and they are not kidding. If you understand ACID, you understand the very soul of what makes a transaction actually work. So, first up, the A stands for atomicity. And hey, this should ring a bell, right? This is our all-or-nothing rule we've been talking about. An atom is supposed to be indivisible, and a transaction is treated the exact same way. It either happens completely or it doesn't happen at all, period.
Next is C for consistency. This is basically the rule that says, don't break the database. A transaction promises it will never leave your data in some weird, half-finished, or incorrect state. For our bank example, it means money can only be moved around, not just created out of thin air or destroyed. The total balance of the whole system stays consistent. Then we've got I for isolation. This is all about what happens when you've got tons of stuff happening at once. Imagine 2 people trying to book the very last seat on a plane at the exact same time. Isolation makes sure their actions don't mess each other up. It's like each transaction gets its own private, soundproof room to work in until one of them successfully finishes and locks it in. And last but not least, D for durability. This is the ultimate promise. Once that transaction is committed and the system gives you the thumbs up, that's it. It's permanent. It's going to survive a power failure, a system crash, you name it. That data is locked in and safe. Forever. Okay, so I know this might sound a little bit in the weeds and technical, but the reality is you rely on this stuff every single day. Let's talk about where this stuff shows up in the real world.
Seriously, think about it. Every time you buy something online or you snag a concert ticket or you send money to a friend, you are being protected by a transaction. Without them, your Amazon order could take your money but never actually place the order. Or two people could book the exact same seat on a flight. Transactions are literally the layer of trust for our entire digital economy.
And hey, for any of you who are working in tech or want to, this is the pro tip right here. For any critical operation, anything with money, inventory, reservations, anything that absolutely cannot fail halfway, you never just cross your fingers and hope for the best. You wrap it in a transaction to guarantee it works right. It's what separates the pros from the amateurs.
So there you have it. You're now in on the secret of the digital safety bubble that protects our most important stuff. My question for you is, now that you know what to look for, where else do you see these all-or-nothing safety nets at play in your digital life? Think about installing an app or uploading a whole photo album. Once you start looking, you'll see them everywhere. Thanks for tuning in.